Welcome back to another video, and in this video it's going to be a continuation from the last video where we introduced this moderate Arduino project. And in this project outline, we have a host Arduino, which is the Mega 2560, and we have an Arduino Nano Every, and that's going to take the responsibility of the partner Arduino. And essentially we're going to look at the pseudo parallel processing kind of application, where we send some input into the serial monitor that gets relayed to the host Arduino. And for our computation, we chose something very simple, just the square root. So because we have a lot of moving pieces here, it is best to divide and conquer the challenges that we may face with writing the code for both of the Arduinos. So we looked into a way to structure that workflow. And again, we don't just want to build everything and then test it all in one because there's a lot of errors that could occur. So we tackle the simplest thing first. You could tackle the hardest thing first, I guess the choice is yours. But for this example, we're going to start with the partner Arduino code, and we're just going to validate the functionality. So again, we're just going to take that input trigger signal, make it trigger some animation. After the animation, we are going to have some output condition, and this will trigger the host. Next, we can work on the host code and validate the functionality of that. So we know a big contributor to the host code is going to be taking some input, recording it as a string, and then converting it to an integer, and then taking that integer and doing some function with it. But in addition to that, we also have to be monitoring for the trigger signal, so this output right here. And then once we get both things working pretty well functionality-wise, they don't need to be exact, we can integrate both systems to test that the functionality between them is working. And then really we can start to develop the complex parts of the code now that we know the communication link between the two is working as desired. So as we develop more complex parts of the code, we can debug and fix them or adjust them as needed. And then we just repeat all of this until we're at the desired result. So the first thing that we can do is start with the partner code. So again, we would need to go to Tools and then select the board. Here it's the Arduino Nano Every. And then we would need to select the right port. But if we look at this code, in the first few lines, we just give a description of it. And then for the Nano Every, we're going to be using pin D3 as the LED output because we're tying that directly to the Arduino. So we can just call that LED1. We can then have our input and output signals. We can just call those D12 and D11. And then if we look at our setup, we call that LED1 and output. So we have that here. We know our input signal is an input and we know our output signal is an output. So this should be actually changed to output. And then we can just initiate the serial monitor here. And we've seen this before. And then what we're going to do, we're just going to set that LED1 output to low. So we're not turning on the LED initially. And we also assign the output signal as low, just so everything starts in a low state. So now if we get into the actual loop that will continuously run, we need to monitor for that input trigger from the host. So we need to read what that input signal is. And we said that the trigger signal is just going to be a short pulse from the host. So we can make an if statement here. And we're just going to say if we read what that input signal is and it's equal to high, well, this is going to trigger the event. So we're just going to print starting code. And we're going to have some delay there. And then we move on to our animation. So we would set that LED pin equal to high. We can delay some amount of time here, and then we can turn it back off. So we set it to low. So now our animation is complete. So we need to trigger the output from the partner to the host. And to do that, again, we just have another pulse function. So notice here in line 17, we set that output signal to low. So really what we need to do in line 32 is pull it high, delay some amount of time, and then pull it back low. So now we can move on to the host Arduino. And now again, we would need to go into Tools, and instead of having the Nano Every, we need to actually switch that to the Mega 2560, and then select the correct port. So if we look at the pins that we are going to be initializing, we're using D3 and D4. So D3 is the output, D4 is the input. And then we have this float here, which we're going to call answer. And then in line 13, we have our function that we can define. So we can just have this square root function. So it's going to return a float. And then we're going to return the square root of that number. And we're actually going to modify this a little bit. We're going to change that float to an int because we know we're going to input some integer. So if we go into the setup, we just set that output equal to an output. We begin our communication for the serial monitor, and then we write that output to be low. Now we've additionally interjected a line of code for 21 to call the input an input, but recall that the digital pins will default to input, so we actually don't need this. And now again, if we enter the loop, we're just going to print, please enter a positive integer to take the square root of. We have some delay, and then we set a string equal to user input, and we use that serial read string line of code. So this will store whatever we enter as a string. But because it's going to be a little bit hard to do some math on a string, we define some user number as an integer, which is going to be equal to user input, and then we have that dot to int. So now our string gets converted to an integer if it follows the correct format. So once we have some integer here, we can just have another if statement. So we can say if user number is equal to 0, this would represent that we had some error or nothing was entered. So we simply say timeout occurred, restarting, delay 5 seconds. But if this isn't the case and we have a valid integer stored in user number, then we enter this else section right here. So what we are going to do is trigger that output pin. So we're going to go high-low on it with a 100 millisecond delay there. So then the partner code would be monitoring for that, and it would start the LED animation. So while it's doing that, we simply call that function and we store the result as answer. And then we can just print some more things to the serial monitor. So we can say you entered and then the number that we entered. And following this, we get pushed into this while loop because our condition is just true. So what we do here, we just continuously print loading. So we print loading, we delay 750 milliseconds, and then we move on to this if statement. So now we're going to read what the input is, and if it's high, we break out of this while loop. But if it's not, we completely ignore this if statement, and we just keep printing loading, and then delay 750 milliseconds. And then eventually, when we break out of this while loop, we print out that the square root of your input is, and we have some delay, and then we print out the answer that we got from that function. And we loop back and do everything all over again. Now, maybe something that comes to mind is this delay right here while checking for that trigger function from the partner. And let's say that trigger comes when this line of code is in the delay. So we know that the trigger is going to go from low to high to low. So if it occurs during this delay, this if statement won't be entered because the host input would just be measured as low. So we would never break out. And there definitely is better ways to do this, but there's a simple way to resolve this potential issue. So if we go to the partner and we just look at the trigger output, what we're going to do is simply say that the output is high for a little bit longer than 750 milliseconds. As long as this line of code doesn't take about 250 milliseconds to execute, we should always be able to catch that pulse function. So if you're testing the partner code just to validate functionality and you need to trigger that input, what you can actually do is have a wire go off the partner input and then either tie it to 5 volts or ground. And then if you look at the 2560, you also have a 5 volt and ground pin right here. So you can use that to simulate the triggering events. So if everything went pretty well, we can actually implement the more complex things here. And the more complex things here aren't really too complex. It's mainly just with the partner Arduino. So let's say that we want more than one LED. And of course we need to call those what they are so we can have their outputs right here. We probably want to write those to low initially, so we can do that. And then we can actually make some animation. And then we said maybe we want to fade them off. So to do that, we can actually use something that we've looked at before, and that's going to be arrays. So we can make some fade array. And instead of manually doing it like we did in lines 34 to 39, we can actually use a for loop. And in this for loop, we're just going to set what that PWM value is using this analog write line of code. So it's going to set the PWM values for LED 1, 2, and 3, delay, and then cycle back through this for loop with the different array element. And on screen right now, there should be a video showing the functionality of this. You can see that we ask for some input. If we get no input, we time out, and then we cycle back through the code. But if we do enter some valid input, then we can see that the computation is occurring. Meanwhile, that trigger got sent to the partner Arduino, and the animation is happening. And then the animation is done, which would have a trigger signal sent from the partner back to the host that's checking for that. And then the serial monitor would give the computational result that we calculated. Now this code is not perfect. There's a few things we could actually change, and there's a few downfalls to this code, primarily on the handling of the input from the serial monitor. This kind of gets a little bit weird if the user inputs a 0 initially, so that's probably the first thing that you would want to correct. But another modification might be how we're actually reading the input that we get. And maybe even more troubling is this trigger event that we do, so this pulling the output high to low, which is fine if you're not doing anything complex, but that actually brings us into the next thing that we're going to look at, which will be communication protocols. So if we need to actually send some complex amount of data, then probably just a simple trigger message isn't what we want to do. And then we might have to look into the options of passing that data or sending some message between Arduinos. But to understand both of these concepts of passing the data or sending a message, we have to know something about standardized communication protocols. And then we can move on to the last project in this course. If you learned anything new, please like, comment, share, subscribe. Helps the YouTube algorithm, and we'll see you in the next video.